All right, section 9.5 is about solving trig equations. And the first thing I want to do is talk a little bit about how to deal with an equation that has infinitely many solutions, because that's going to happen with a lot of the equations we solve here. Let's look at this first example. You got sine x equals a half. So here I've graphed y equals sine x and y equals a half. And notice there are infinitely many places where the two cross. I'm just going to mark some of them on here. And so we need to come up with some sort of notation for this. So first up, let's just look at the between 0 and 2 pi. So like the first cycle of sine. Inside of there, we've got two solutions. We've got pi over 6, and this other one is 5 pi over 6. I've got that written here, but let's talk about how to find that. Okay, if sine x is 1/2, we should know that the reference angle for that, just from knowing our special angles, is pi over 6, because sine of pi over 6 is 1/2. And since it's positive 1/2, I'm going to draw that reference angle in the first quadrant and in the second quadrant. So when I do that, I get pi over 6 here. When I draw the same angle in over here, same reference angle, it's going to give you 5 pi over 6. So that's how we get those two solutions. Now, if you look at the rest of these solutions, if we start at pi over 6, if we add like one full cycle onto the graph, or onto there, well, we get this next solution. So that's adding 2 pi. The distance from here to here is 2 pi, so this distance is also 2 pi. And we can add 2 pi on again and get to this solution, and again to get to this solution. And if you subtract it off, you get this solution back here. So what that does, that gives us all of these solutions listed there. And the way we write this out is by saying it's x is equal to pi over 6 plus 2 pi n. That n means any integer. So pi over 6 plus any whole number multiple of 2 pi will get us a solution. And so all of our solutions here are pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. Because 5 pi over 6 plus 2 pi n similarly moves us from this to all the other solutions. All right, let's do another example. Find all the solutions of cosine x equals root 2 over 2. Now, I want to do this on the graph, and I want to do it sort of maybe a more normal way. But let me see if I can draw this line correctly. It's not wanting to snap to a straight line. I must have changed some settings. Anyway, when we do this, we get a solution here, solution here, solution here, solution there, and infinitely many more in both directions. So of course, what angle has a cosine of root 2 over 2? Well, pi over 4. And that's this solution right here. So we get pi over 4 plus any multiple of 2 pi. That gets me one set of the solutions. The other solution, we could either start from here. I'll tell you what, I'm going to do that in green. We could either start from here. Now, what is that? That, if you look at the graph, you can count across and say this is 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4. So this green one is 7 pi over 4, and then plus 2 pi n to get all the translates of it. Or you could start from this one back here, which is negative pi over 4. So that stuff in that big green and red box, you can include either one of those two. Both of those represent the same sets of solutions. Of course, another way you could do this is you could come up here and say, well, my reference angle is pi over 4. And cosine is supposed to be positive here. So that means it can be in the first quadrant or the fourth. So that gives me this angle, which is pi over 4. Or this angle down here, which is 7 pi over 4. Or you can call it minus pi over 4 if you want to think of going down instead of going around. So both ways get you the correct answer. All right, I want to do one more. Find all solutions to cosine x equals 0. All right, let's do that one with the graph and with the graph and by knowing our special angles and the simple trig chart. Okay, all the solutions. Let me pick a new color. If cosine x is 0, that there's a solution here, 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 and if this continues, there'll be a solution here, and so on. So all those orange dots are our solutions. If we look again at everything between 0 and 2 pi, let's see, the orange dots we get, let me change this back to orange. The orange dots give us pi over 2 plus 2 pi n, and also 3 pi over 2 plus 2 pi n. So you could write your answer like that, and there's nothing wrong with it. But we can make this a little more compact. Reason is, if you look at the distance between these, the distance from here to here, and then the distance from here to here, those distances are pi. So we can collapse this into just pi over 2 plus pi n. And the reason, looking at the graph, the reason we can do that is because the solutions are equally spaced within the first within this first period. Notice these are equally spaced. It's always pi between them. That wasn't the case for the other ones. It only works out like this because it happens to be on the x axis. Now, if you do this one by using the unit circle instead, you draw your unit circle around here and you'd say, let's see, a point on the unit circle, its x-coordinate is cosine, and its y-coordinate is sine. And so we're looking for the one where cosine is 0. So where's the x-coordinate 0 here? Well, here and here. And notice that's up here at pi over 2, and then down here at 3 pi over 2. So you could think of this as being pi over 2 to get that much, and then around another full revolution, or around 2 pi to get the next solution. Or you could also think of it as being, this is pi over 2, then every time I go halfway around, I get to the other solution. So that's why we can just do pi in there. All right, we're going to do some more equations, but we're going to stop here and pick up in the next video.